Hello and welcome everyone. Today we are going to do some more tool calling and function calling, and we'll be taking a look at various different model sizes that Llama 3.1 provides and what's the function calling capabilities that come with it. So they really went hard and they really talked a lot about the function calling or tool calling capabilities of these models. And I have found something very interesting that I wanted to share with you guys today. So of course, the model comes in three different flavors, 870 and 405B. 405B is out of my league. I mean, I cannot run this locally. However, I can run 8 and 70B parameter models. So 8 takes about 6 gigs, so it's very easy to do on any consumer grade GPU. 70 billion is slightly harder. You need about 44 gigs of VRAM for 4-bit quantized 70 billion model. And I happen to have 4 NVIDIA 3090 GPUs in my AI rig. So I have sufficient VRAM for running a 70 billion parameter model too. So let's do this. Let's take the 8 billion and 70 billion parameter model and then run them through this new test suite that I have built. And I wanted to show a case to you guys. What does this test suite have? So in my last video, I went in depth and I showed you guys how you can do a function calling. How can you have a model associate certain tools to it, and you can bind tools to model. And then once you have bound the tools, you can generate a prompt template. You can generate a system message for the prompt where you can tell the model that, hey, you can utilize certain tools that are made available to you. And LangChain in turn takes those tools that you have bound to the model and it proceeds in with the prompt generation using the chaining methodology that LangChain provides, and you get a runnable and you do an invoke on that, and then you pass in a sentence, and in response to it, your model then attempts to do a tool call if it thinks a tool call is required. Right? So in our use case, let's run this one particular function calling example that I have. So Python, and this is 04B and function calling example.py. And I'm going to run this and I will show you that this is actually running on my server, which is in my basement, on the port 11436, right? So I have configured it to be 11436, and that is why it is running on that particular port. Normally, this runs on 11434. So these are the 11436 GPUs, so GPU 1 and GPU 3. And this is where the model is being loaded. So once this number turns to like 21, 22 on both these GPUs, this is where the model is being split. And that's when you will see, yep, now the model is loaded completely, and you will see that the model is being accessed, and you will have the result now over here. So we get the result. That is pretty cool. The model was able to identify that in this particular sentence that we passed over here, right? So the sentence that we passed was, what is the weather in Woodbury, Minnesota? And in this sentence, it was able to figure out that, yeah, it potentially needs some kind of tool call, and it had a weather tool available to it. So let's take a look at the tools. So it had the weather tool available to it, and as a part of that, it performed the tool call and we got the result, right? So this is a very simple, straightforward tool calling example that we have. Now, I have converted this tool calling example into a test suite. And what have I done over here is, so let's take a look. So I'm going to close this. So now the top part of this code looks exactly the same, right? So we define our model, we define our LLM and bind our tools with it. So model with tools, we bind these two tools to it. And then we create our prompt exactly same as previous. We create our prompt over here, and we then, this is where we create the test suite that I have, right? So once we have our runnable, before running the execute on it, what we do is we just define a bunch of city and states, right? So these are a bunch of city and states just randomly chosen by me. And what else it is doing is there are a bunch of sentences that I have, right? So these are weather related sentences, like what is the weather today in, and we can have a location passed in over here, right? So what I'm doing is I'm just creating some random sentences which are mix of these and some city and state, and then I am just creating the test suite size over here, right? So if I say 10, then we will generate 10 sentences and we will add it to this particular array over here, right? So this test sentences array is empty at the start, and what we are doing is we are randomly choosing one of these city and states, and then we are choosing one of these sentences, and then we are associating the location over there, and we are creating 10 sentences, and this 10 number can be increased to 10, 20, 30, 40, 50, 100, whatever, and it will create random combinations of these sentences with these locations that we can pass into the model, right? So after we generate these random sentences, we're gonna just print them out over here so we can see how they look like, and that is where our actual test suite will start running after this. So in this suite over here, you see that we are looping over each test sentence, right? So if we have 10 sentences, we are looping over each one of them, and we are going to call the agent request generator runnables invoke method. We are going to call that passing the initial request as one of the sentence over here, and then we loop over this and we attempt to see whether a function call can be made or not. And then we initialize a function call counter at the top. And if a function call is being made, then we increment the count by 1, right? So we can then keep track that at the end of this whole code, how many times the LLM decided that it was going to do a function call. So this is critical, because in this section over here is where we are checking whether there was a tool call response in the response back from the LLM. So if we did have a tool call response, we are going to execute that tool. But the point is that we need to check whether the LLM decided that it has to do the tool call or not. And then at the end, once the whole loop is over, at the end we are just going to print in each loop we are going to print how many times the function was called, and at the end we are just going to take the total number of function calls that were made and divide it by the total number of the size of the test suite, right? And then multiply by 100 to get the percentage of the tests that were passed. So let's run this and let's see what the example will look like. So if I go ahead and I execute this particular code, so you see the name is 4D function calling test suite Llama3.1 70 billion over here. And why 70 billion? So I've in a way put this particular model as 70 billion parameter model over here, and I have a copy of this code over here which I will show you guys in a second and why I do have it like that. But if I run this particular test suite now, you will see that the initial model load takes some time for sure. So you will see that on this 11436, which is GPU 1 and 3, the model is being loaded. And once the model is loaded, then so loop 1 will take a little bit of time, but once the model is loaded, it will go by faster. So these are the 10 random sentences that have been generated, which are, can you tell me the forecast for tomorrow? Is it going to rain tomorrow? How is the weather in Houston and all that? So it's gonna just create these sentences. And now one by one, once the model is loaded, it is gonna attempt to do the function call, right? So let's see what happens. So the very first one, it did the function call. The second, third one was also successful. Fourth, so fifth. So for this sentence, function call was also successful. 7, 8, 9, 10. Wow. So for all the 10 sentences, it actually did a function call, right? So let's take this last example so it will make more sense. So in this loop 10, it picked up the 10th sentence, right? So what is the weather today in Miami, Florida? And the last AI message was this one. So the content was none, which is what we want. We do not want our model to hallucinate and send a response back. We want it to say, nope, nothing, just do a function call for this. And this is what we are looking for. Was there a tool calls entry in the response? And yes, there was. There was a get current weather, and there was an argument that was provided over here, right? And not only did it do the function call, it formatted everything perfectly, so much so that the tool output was generated too. And this was one of the requirements that, hey, if you are provided with a particular sentence, then you should attempt to do the function call for this, right? And let's see now. So this definitely was 100% success rate. You know what? While the model is prime, I'm gonna run this again, and it will generate 10 other random sentences. And let's see how does the model respond again for newer random sentences, and see what happens over here. And it appears that the model is doing pretty decent. So I think it missed one of the function calls, but it's still doing pretty decent. 90%. So let's see which one it missed, and let's try to locate that. So on loop 6, there were 5. Loop 5, there were 4. So somewhere over here, it looks like it missed. Loop 3, loop 2. So in loop 1, there was one function call. Loop 2, there was second one. Loop 3. Okay, so this is the one where it missed. So we asked, can you tell me the forecast for tomorrow in Austin? And instead of doing the function call to get the weather data, it responded, I cannot help you with that information, right? So it did miss. It's not perfect. It did miss. So we have 90% of response at this time. So let's run it again while we are here and see how much is it, can we replicate it? So I'm gonna run this again. And I'm going to tell you my results, because I've also run this for over 1,000 times, and I have results based on that too. But I want to show you guys live that what is the hit miss ratio for these sentences over here. So 100% again, this is pretty awesome. And then I'm gonna run this one more time, and then I will switch to the 8 billion parameter model, and I will show you the shocking results from 8 billion parameter model too. So this is the last run for the 70 billion parameter, and then I will move on to the 8 billion parameter model. So pretty cool, 100% again, right? So most of the times you will see 100%. In my use case, and I have run this for 1,000 random sentences, and it has been over 97% accurate for the sentences that I have provided to it. So 97% accuracy in terms of function calling is what I felt, and that was awesome. And it is not that we are only providing one particular method to it, one particular tool to it. I did provide 2 tools to it. So it made a determination that even though I have 2 different tools provided, it made a determination that it has to get the current weather. And if you noticed, I did twist some sentences like tomorrow, right? So there is a time component over here to today, right now, and still it did not want to go to get the system time. It understood that the question is more relevant for weather, and it just went in and passed in the weather. And because this method doesn't accept a time parameter, it just went in and did only the weather function call. All right. Now let's switch to our 8 billion parameter model over here. So in 8 billion parameter model, if you see, the only thing I have changed is, well, yeah, I'm switching it to the server 11435, which in my case is GPU 0 and 2, right? So these are the 2 GPUs that are associated to 11435 Llama server. And I'm using the 8 billion parameter model. So even though there are 2 GPUs allocated, I don't even think GPU 2 will be used. The whole model can be loaded over here on GPU 1. So let's go down, and everything else in the model is exactly same, right? So we have the same set of test suite, and we have everything exactly same. 10 times you're going to run this, and we will see what the result is, right? So let's keep the 8 billion parameter on the top and 70 billion parameter on the bottom, and I'm gonna run the 8 billion first, so the model gets loaded over here, and then I'm gonna run the 70 billion right after. So of course the 8 billion model is fast, so we're gonna see that the fastness of the 8 billion model comes with a cost, right? So you see 20% accuracy in terms of function calling capabilities, which I mean, I get it, it is a small model, but the way they were claiming how nice and how good it is for function calling, I would have expected more than 20%, right? And this is reproducible. It gets worse sometimes. Let me run this again, and I'm gonna run this bottom one again. So the top one is the 8 billion parameter model, and the bottom one is the 70 billion parameter model. And of course, I understand 70 billion is a more smarter model, but I mean, this is kind of not acceptable. The 0% success rate out of 10 calls is I mean, I cannot explain it. 0 versus 100%. So the difference between 3 the 8 billion versus 70 billion is huge. It is huge. And I'm gonna, you know what, let me change the 8 billion parameter model's test case to 100, right? Let's do this 100 times. And let's keep, I don't think the 70 billion 100, it will take a lot of time, but we can definitely do, if not 100, we can do maybe like 25. 25 for this. Oops. So 25 for this and 100 for 8 billion. So the top one is 8 billion and the bottom one is 70 billion. So 8 billion will run for 100 times, and this will run for 25 times. And as you can see, over here 100 sentences have been generated, and over here we are going to run it for 25 times on the bottom, right? So let's see, this would be a very interesting result. So already in 13 loops, it has only done one function call, right? Which is, I mean, there's no nice word for it. I mean, the very first word that comes to my mind is, it's very disappointing. I do not like this. I've always been fan of the smaller 8 billion parameter model, but for whatever reason, it is giving up on the test suite that I have built over here. And its big brother, 70 billion parameter model is 100% again. And let's see, I'm gonna run this again. Looks like 50 runs of this corresponds to 25 runs of this. So is it fast? Yes. But how good or how how do you feel about a model being fast or not if it is not accurate? So it generates, it hallucinates, generates, but it doesn't do good with function calling. And on the other hand, a 70 billion parameter model is a champ over here. And I cannot stop singing, like how good the 70 billion is. And that makes me, wonder how good the 400 billion parameter model is. Like, I would just love to run that in my home lab locally over here. And the fact that I cannot sucks, there has to be a way to quantize it to so much that I can run it locally. Wow. So look at that. After 100 different function call attempts, only 6%, right? So only 6 of them passed, right? This is totally disappointing results from Llama 3.1, and 100% success rate out of 25 for this run and 25 for previous run, right? It has always been close to 100% in every single use case that I have tested it. So what I'm gonna do is, in my use case, I'll be dedicating one of my servers specifically to Llama 3.1 70 billion parameter, right? So the 11436 server would be for Llama 3.1 70 billion permanently hosted over there. And I'd be doing the function calling only for Llama 3.1. The success rate over here is huge. I absolutely love it. And I would like to hear your guys' thoughts and views on this. Like, have you run this in any scenario? And how are you feeling the differences between 8 billion and 70 billion parameter model? This just leads me to believe that any kind of code generation task too, like usually I would be just using a smaller model for code completion and all that on my laptop, but I don't know if I feel as comfortable with that anymore, right? So maybe the DeepSeek Coder, Codestral, and some other models are, good enough, but not Llama 3.1. I mean, I know I shouldn't be comparing function calling capabilities to code generation capabilities. Those are two different test suites and benchmarks altogether, but it just makes me uncomfortable seeing a result this bad from one test suite and this for a different big brother of the model. Just makes me want to use the big brother, which is obvious, right? I mean, it's 70 billion, it is supposed to outperform, but I would have expected slightly better results with its little brother. All right, thank you guys for watching this, and I'd love to hear your feedback. Please comment and let me know how you think about the differences between these two models.